Hi there. Thanks for coming back out and joining me. Today I'm going to continue our discussion about validated boot. And actually, I'm going to build the validated boot infrastructure for you using an application called ValBoot that operates in a TSO-ISPF environment. I only have about 10 minutes, so I'm going to go ahead and share my screen with you so we can get started. So you can see I'm logged on to TSO-ISPF and my cursor's on the command line. So from the command line, I'm going to type TSO dollar command line interface, comma, asterisk ValBoot VB. Now, when I hit enter, the first thing that we're going to do is check to see if there are any validated boot certificates in the RACF data store. And there aren't any. I deleted them earlier before I began the demonstration. When I hit PF3, we display the primary menu. Now, the menu is very straightforward. The upper part of it deals with key rings. The lower part of it deals with certificates. There are many other functions here that we can spend time on. And if you would like more in depth, please send an email to support@newera.com. We'd love to hear from you and spend more time on validated boot. Now, the first thing we're going to do is we're going to build a key ring. Now, our key rings are prescribed and defined as validated boot signing key ring, but you can append to them a high-level qualifier, usually a user ID, for example, AROBY1. Uppercase, lowercase, everything will get folded to uppercase as we move forward. If we want AROBY1 to also be the owner of the keyring, we just check. Now, at this point, we have done everything that's necessary to build the keyring, all the profiles and permits that are necessary to make them operational. All we need to do is click on the left-hand side to generate all of the commands and display them on the screen, as you can see. So up at the top, we have the command syntax for adding the keyring. Right below that, for creating the R data lib profile. Below that, all the permits that we want to the profile. Now, the user and the owner automatically got permitted, but we can permit others. So for example, JLOT1, we can permit additional people to the facility class profile, GBags1. So now the next step is simply to submit this to RACF and have the commands executed. And they have been. And you can see something that's interesting about ValBoot. It has a trace function that allows you to see all the commands that were issued and the replies from those commands as sent by the system. So the profile was added, excuse me, the key ring was added. The R data lib profile was added. The permit of AROBY1 was added. I'll scroll down a little bit. The facilities class profile was added. And the permit of GBags1 was added as well. So now we have everything that we would expect. The next step would be to do a refresh, which we did. So all of those commands, the keyring, the profiles, the permits are now all active within the RACF data store. When we hit PF3, we can actually see the keyring as it exists now. So here it is, and we can show its detail, but there isn't much to show now at this point because there aren't any certificates actually connected to it. So if we back up and look down in the lower part of the panel, we can begin the process of adding certificates. Now, we recommend two certificates, a CA certificate that will be used to actually authorize and sign the second certificate, which will be used for actually signing the resources that we are going to want to encrypt before we send them over for a list-directed IPL. Now, our certificates, much like our key rings, have a prescribed format, but you can add a suffix to them, and we do recommend that for something like CPC. Oh, excuse me, I'm on the wrong line there. Something like CPC1, so a KEC. Those names have to be the same, and that helps us to manage these certificates better, particularly when we're in the process of renewing them. We can give them common names. And so now we have our key ring. Now we have our two certificates. We'll go ahead and actually update them, generate them, and connect them to the key ring itself. So now we can see our key ring up at the top. But if we chose to, we could actually change key rings now at this point. We're not going to do that, but that is a possibility. We see all the commands that are necessary for generating the certificates, the CA certificate and the signing certificate. Well, we'll go ahead and do that. Now we're generating an RSA 4096 key, private public key pair. So that takes a little bit of time, along with a NIST ECC 512 private public key pair. We're going to use that upper certificate to actually sign the lower one. We could use a self-signed certificate, but we don't think that's the best practice in the context of the clean room and the signing process itself. Should be done shortly. Okay, so it's done. You can see that we have generated the certificate. It won't take effect until we do a setrops refresh. We have connected it to the certificate, to the key ring. No reply was received. We generated the second certificate and we signed it with the first. PF8 down. We hooked it to the key ring as well. And then we issued a setrops refresh. When we hit PF3, we can now see the key ring. It has two certificates attached to it. You can see that over on the right. We'll show the detail. Okay, so now what we're seeing are the certificates as they are attached to the key ring that's going to be used in the signing clean room environment. But what we have to do to complete this process is we need to export this certificate. And to do that, we can use our export processing model. We can keep a registry of our actions, and we can simply now pass the certificate forward and create it into the form or embed it into an export data set. What we would do now next is we would simply send this data set name to our associate who's operationally responsible for the HMC. He would import it into the HMC and move forward with it. We could also send him this, which is a copy of the registry that contains the information about the creation of the key ring and the certificates. particularly important here is this fingerprint, because it's that fingerprint that's going to be used at the HMC to validate that the certificate that was imported is actually the one that was intended. Okay, just backing up here. So there's a lot more to discuss here, a lot of detail we could get into, lots of different ways in which these key rings can be created, and particularly their APPL data can be created and harmonized with the key rings themselves. Let me know if you'd be interested in listening to or having an additional session. Again, support@newera.com. Thank you so much for coming on and joining us. Look forward for the next session, which will deal with the same topic, but using a different environment that we refer to as certificate intelligence. Thanks much. Bye-bye.